Hello, Algebra 2. Here is this week's objective. This week we want students to learn how to solve an exponential equation by finding a common base. We only have one objective this week, but I still have two separate screencasts for you. In this first one, we're going to talk directly about this method of finding a common base. The separate screencast is going to talk more generically about solving exponential equations. Not necessarily by finding a common base, but using another method that you should already be familiar with. So we technically only have one objective, but there are still two presentations that we want you to watch this week. So here we go, on to slide 2. So to put this in a little bit of context, last week we asked you to learn how to graph an exponential function, including transformations. So if we took a function like this one, which you should have some idea of how to graph that. This is an exponential function with a base of 2. Hopefully you can see that the graph has been shifted to the right by 3 units and up 2 units. So if you wanted to, you could sketch this graph. Well, we could use graphs to transition into solving equations by just saying, what if I were to take that equation and replace the y value with a number, like say, for example, 6 equals 2 to the x minus 3 plus 2. Well, now you have an exponential equation, and we would want you to try to solve this equation, which solving always means find x. So before we actually look at this particular equation, let's maybe think a little bit about the strategies that we have available to us. So methods of solving that you should already be familiar with include solving by graphing and solving algebraically. And so we want to talk a little bit about those two options. So let's start by considering solving by graphing. Okay, so as we pointed out last week, we explained graphing, and you should now know how to how to graph an exponential function. That means you could potentially solve exponential equations by graphing. Say, for example, this first equation. The way you solve any equation by graphing would be to graph the left side and graph the right side of the equation. So for this first equation, what we would want you to do is draw this graph. Now that's a pretty simple exponential function. It has a base of 2 and it's been shifted left 3, so hopefully you can draw that graph without too much trouble. And then you would also draw this graph, which is the right-hand side of the original equation. What you would then be looking for is, where do those two graphs cross? Wherever those graphs cross, that should be your solution. So since you guys should know how to graph, at this point I would recommend you pause the presentation, get out some graphing paper, or maybe I guess you could use Desmos, but it'd be good practice if you would do it by hand, and see if you can solve these 4 equations. And when you're done, join me on slide 5 and we'll talk about the answers. Okay, so if you drew these graphs, I hope you were able to get the answers to equation 1 and equation 2. The point of intersection for the first equation is x equals -1, and for the second equation it's x equals 2. I would also just remind you that you could verify these results by plugging them in. So if you would just plug in a -1 right here, then you would see that you do actually get a 4 for the left-hand side. And same thing, if you plug in 2 over here, you would see that it does come out equaling 7. There shouldn't be any problem with extraneous solutions. That's not why I'm telling you to plug it in. I'm just saying it's an easy way to check your work. Now, if you tried the third one, you probably saw a problem, and it's something we've encountered before by graphing. Here's what the graph of the third one would look like. The left-hand side has been graphed in red, the right-hand side has been graphed in blue, And yes, I used technology to draw those graphs. I didn't draw them by hand. I hope you can see from this picture that the graphs definitely do cross, so there is a solution, but they appear to cross at some point between 0 and -1. And if you didn't have a graphing calculator to tell you exactly what the point of intersection was, it would be a little hard to see what the answer is. You can't just assume that that answer is -1/2. It might be -0.6 or something else. So this is a familiar problem and a familiar limitation of solving by graphing. The last problem, I hope if you did it, you saw that the graphs never cross. And so there's one thing to know about exponential equations. Sometimes there is no solution, because if the graphs don't intersect, then there's no solution. So again, solving by graphing, this is not new information. We should already know this from earlier units. Solving by graphing is hard to do if you don't have a graphing calculator, because that means you're going to have to draw the graph by hand. And it also means the point of intersection might be hard to determine. Unless it's a nice round number, you need to be very careful about assuming what the values are, what the coordinates are, when you see graphs crossing that are in between points on the grid. So just be careful about solving with graphing, especially if you are being asked to do it without a calculator. Okay, so now let's transition and talk about solving algebraically. If we take a look at this equation and we think a little bit about solving algebraically, I would hope that you might be able to start isolating the variable. If you think carefully about what's going on here, it would make sense to first subtract 3 from both sides. And now your equation is going to look like this. And then you might even get the idea that I need to divide both sides by 2, and that would get you to here. But that's about as far as I would expect you to be able to go with this, because now, how do you isolate the variable? The problem is, what operation makes that go away? And there's not a good answer, at least not for now. So this is the problem with solving exponential equations algebraically. We do not have an operation that will isolate a variable that's in the exponent, at least not yet. I'll give you a little spoiler alert. That will change when we get to Unit 9. Now, while we don't have an operation to isolate the variable in the exponent, that doesn't mean there's no way to solve this. And here's where we get to our real objective for the lesson. There is a way you can solve these equations sometimes, and that's by using a method called finding a common base. Before we illustrate what that method looks like, let's talk a little bit about what we mean by find a common base. Imagine you had a base and it was raised to some power, let's call it C. And then imagine you had the same base and it was raised to another power, call it D. Well, if you would just look at this statement, if B to the C is equal to B to the D, I hope you can see that it stands to reason that C has to equal D. And this is true no matter what the base is. I don't care if the base is 2, 4, a half. That's why I'm using a variable b here. The base could be whatever you want. The important thing is that the bases match. And that's what we mean by common base. If you have the same base on both sides of the equal sign, then the exponents have to be equal. So if we try that strategy on the example to the left here, I hope it's not too hard to see that the right-hand side could be written as 2 to the second power. I could also say it's 4 to the first power, but 4 to the first power doesn't help me because you don't have the same base. One side has a base of 2, the other side has a base of 4. The goal is to get a common base, and that's why you want to rewrite the 4 as 2 squared, because now you have a base of 2 on both sides. Now, as we said on the right-hand side of the slide, if the bases match, then it stands to reason that the exponents must be equal. So that means x plus 3 has to equal 2. And if you're trying to solve for x, all you got to do is subtract 3 from both sides. And now you have an answer. So that's the method of solving by finding a common base. If you join me on the next slide, we'll do a couple more examples just to make sure you got the hang of this and to show you a couple things to be careful of. Okay, so let's start with the example on the left. We want to solve by finding a common base. The thing you don't want to do is immediately try to get the common base. If you look at the left-hand side, you know that you have a base of 2. Well, if you're trying to think, how do I write 10 like 2 to some power? You can't, and you shouldn't, because you need to take care of some other things first. So specifically, you need to get rid of this negative 2. So the first thing to do is to move the 2. And now your equation is going to look like this. And then I still wouldn't try to get a common base yet. I would get rid of the 3. So if you get rid of the 3, now you're in a position to find a common base. And I hope you can see what the answer is at this point, because this is similar to the problem that we just did. So if 2 to the x is equal to 2 squared, then clearly x equals 2. The problem on the right shows you something else that you might run into. When you first look at this, it looks like, well, you have a base of 4, and over here you have a base of 8. So should I make the common base 4, or should I make the common base 8? Well, the answer is neither. There's no easy way to take the left side and make it a base of 8, and there's no easy way to take the right side and make it a base of 4. So really what you need to do is find a common base that's different from both of those numbers. And the way to do that is to recognize that 4 is 2 squared, and 8 is 2 cubed. So I'm replacing both of the bases with a base of 2. Now from there you have to remember your exponent properties, because notice I have a power raised to a power. When you have a power raised to a power, the rule says you get to multiply the exponents. So this side becomes 2 times x, and this side, the exponent becomes 3 times x plus 1. Don't forget, the entire exponent, x plus 1, needs to be multiplied by 3, so you definitely need parentheses. Okay, well, now we've got our common base, which means now we can just look at the exponents. 2x has to equal 3 times x plus 1. If it was up to me, I would distribute the 3, so that's 3x plus 3. Now you want to isolate the x, so I could subtract 3x from both sides, and I'm running out of room here, so I hope you'll excuse me for not showing exactly all of my work, but I hope you can follow along. I'm just subtracting 3x from both sides. And if negative x is equal to 3, well, now if I multiply both sides by -1, I will get x equals -3. And there's your answer. So now, what about this problem? This is a problem from earlier in the slideshow. And we had done some initial work, and I'll do it again to remind you. If we move the 3, you get this, and then if we divide by 2, we get this. And now what? How do I get a common base? Well, you can't. There is no way to get a common base in this problem. There's no way to take the right-hand side, 3/2, and make it 1/2 to some power. There's no way to take both of the bases and change them to some different number. This just can't be done. And that's the problem with this method, finding a common base. Unfortunately, it's not always going to be possible to solve by finding a common base. And this problem we were just looking at is an example of one that can't be done. If you don't have a calculator, then the best you can do is you can see that there is an answer. These graphs do intersect, but you can't tell the exact point of intersection. And so really the only way to solve this problem is by graphing with a graphing calculator or Desmos.com. So at this point, I would invite you to try that. Whether you have a graphing calculator or if you don't, just go to Desmos.com. Again, remember you're just going to take the left side and you're going to graph that as one function, and then you're going to take the right side and graph it as the other function. By the way, if you didn't know this in Desmos, the way to find points of intersection, once you graph the two functions, if you just click on either one of the graphs, then clicking on the graph, it will automatically show you significant points, such as points of intersection. So if you click on, once you have the two graphs shown together, click on either graph and you should see a dot appear where they intersect. And if you would just hover on that dot, or maybe you need to click on the dot, the coordinates of that dot will appear, and then you'll know exactly the location of the point of intersection. So if you would pause for a minute and try that, and after you've done that, you can come back here and you can see that I will have the answer on this slide. So hopefully after using a graphing calculator or using Desmos, you got the point of intersection is -0.585. That answer has been rounded to the third decimal place, I believe. I don't think that's an exact answer. So if you don't get a nice round number, we typically will tell you to round to a particular decimal place. And this about wraps up our lesson. So let's go back and review the objective one more time. So our only real objective was to teach you how to solve an exponential equation by finding a common base. That's really the only new information you should have got out of today. Exponential equations can also be solved by graphing, but that is not a new method. That's a method you should already be familiar with. Any equation can be solved by graphing. You graph the left side of the equation, graph the right side of the equation, and you look for where they cross. If you don't have access to a graphing calculator, the drawback is you have to create the graph, and the other drawback is you may not be able to tell the exact answer. You could just be able to see that there is an answer or approximate it. For practice, if you will join me on the last slide, we'll talk about how we're going to check your understanding of this new method. So here are 6 problems that we want you to try. I promise you every one of these problems can be done by finding a common base. Sometimes you cannot find a common base, but that is not the case with any of these 6 problems. You should be able to get an answer for all 6 of these problems by finding a common base. Now, that being said, please don't think your answer is always going to be a nice round number. You need to get a common base, and then once you have a common base, you set the two exponents equal to each other, that equation may or may not have a nice round number for an answer. So if you get a fraction or a decimal for your answer, please don't think that it's wrong. Anyway, we want you to try these 6 problems by finding a common base. If you have trouble, you're welcome to post questions on the discussion board or email me. And in It's Learning, we've created an assignment for you to enter the answer to these 6 problems. So try these problems on paper, and then once you think you have the answers, go to It's Learning, and you will just be uploading your answers. You will not be uploading any of the work. That's it for this screencast. Again, please make sure you watch the second screencast because there is more we want to say about solving equations. But this is all we really have to explain as far as solving by finding a common base. So good luck.